Today I'm presenting findings from a lichen survey conducted at Walter Hall Park to investigate the impacts of air pollution on ecosystem health. I hypothesized that air quality within the park would be better than near the busy road outside the park, resulting in higher lichen cover and greater lichen diversity within the park. This study investigates an important ecological principle. Organisms are sensitive to environmental stressors, and the presence and diversity of organisms can be used to assess environmental quality. Lichens are particularly useful for this because they're symbiotic organisms. They're a fungus and algae living together that directly absorb pollutants from the atmosphere. Sensitive growth forms like fruticose and foliose lichens can't survive in heavily polluted areas, making them excellent bioindicators of air quality. Pictured on the screen are examples of these type of lichens or forms. Foliose lichens are pictured on the left and the right. They're the leafy and flattened lichens with distinct upper and lower surfaces resembling small overlapping leaves or lattice. Crustose lichens pictured in the middle form a thin crust-like layer that resembles sort of like a coat of paint. And fruticose lichens pictured on the right are three-dimensional and shrubby or hair-like growing as tiny bushes, tufts, or hanging strands. Looking at the data, I sampled 5 quadrants at each location. Site A inside the park, away from the road, right next to a water source, had an average crustose lichen coverage about 25%. Site B, located near the road where vehicle emissions are highest, had only about 12% crustose coverage. More importantly, fruticose and foliose lichens, the pollution-sensitive growth forms, appeared exclusively at Site B, however, very low levels. They were completely absent from Site A. This pattern supports my hypothesis that park interior has cleaner air that allows more total lichen growth, while the roadside shows limited lichen diversity despite being exposed to sensitive species colonists. What does this mean biologically? First, our data demonstrates that air quality significantly affects species composition. Clean air doesn't just mean more lichen, it means more diversity. Second, we've identified a real-world example of pollution-sensitive indicator species. Fruticose and foliose lichens are sensitive to air pollutions, and their presence or absence provides immediate information about environmental conditions. And third, what I found most interesting is how a decline in lichen diversity can trigger significant ripple effects throughout ecosystems. Lichens serve as a vital ecosystem engineers, profoundly influencing their surrounding and maintaining ecological balance. They provide food and microhabitats for invertebrates, help trap airborne particles, and contribute nutrients through decomposition. If lichen diversity declines due to air pollution, we lose these ecological functions, which affect herbivores and nutrient cycling and potentially indicate broader environmental stress affecting other species. This demonstrates how a simple survey of lichen can reveal a complex ecosystem relationship. Thank you for listening.